Hello, welcome back students. So today, as I already told you, we have to begin with a new chapter, a new unit. This unit is about wind energy conversion systems. Okay, previous module or previous unit we have seen that we were purely dealing with solar energy. Okay, how solar energy can be converted to other useful form of energy. You can convert them into heat energy, you can convert them into electrical energy, okay. You can convert them into many other forms of energy, maybe potential energy. So different conversion methods we have seen. In this unit, we will see how wind energy can be converted into other useful forms of energy. You may convert them into mechanical energy, you can convert them into heat energy, you can do them into electrical energy like that. So very interesting chapter. You will come across with various technology, modern technology used for this purpose. Okay. The chapter name is Wind Energy Conversion System. Usually this wind energy conversion system is abbreviated as Wecs. Okay. In Wecs, W for wind, E for energy, and C for conversion system. There are innumerable ways by which wind energy can be converted into other forms of energy. Okay, you will see one by one. Before that, you will be interested to see the relevance of wind energy conversion system. If you make a survey around, you will see there are many global giants who convert or generate a huge amount of electricity from wind energy. Okay, this is one of the energy conversion. Okay, don't think that always wind energy is converted into electricity. No, you can convert them into other forms of energy as well. Okay, but here we focus primarily on the electrical energy. You can see China is standing at the top with the highest electrical generation from wind energy mills, with a value around 6,800 megawatt. Just below that, India stands with the biggest wind energy farms located in the Kanyakumari district of Tamil Nadu. This farm is known as Opendal Wind Energy Farm. This globally stands at the second position, with United States at the third, and still the fourth one also is occupied by India. So we have a big giant wind energy farm at the Jaisalmer, Rajasthan state. Okay, so there are many other globally well-known, renowned companies, firms who are running wind energy farms worldwide. Okay, so anyway, this slide is given to show you that what is the importance of wind energy around the world. Okay, in this present unit, we will be primarily at the beginning we will be talking about what is actually wind. Okay, what is the physical reason for wind production? What is wind actually? And winds are of different types. One of them is sea breeze and land breeze. This is one of the wind, and the winds are of different nature and different origin. Okay, there are different reasons for different types of wind. We will be talking about those winds which are useful for energy mills. Okay, we will not discuss about any other type of winds. Only those winds which are useful for energy generation from the windmills. So one of them is sea breeze and land breeze. We will see what is sea breeze and land breeze, and we will also see about different other type of winds and how they are produced. Okay, basic reason for many types of winds, and we will also see the basic principle of wind energy conversion system. Okay, what is the physical principle of working behind a Wecs system or a wind energy conversion systems, and what are the different parts of wind energy conversion system. Okay, there are different parts. which need explanation, separate explanation, that will be discussed in this unit. And a classification of Wecs. Okay, different designs are there. The wind energy conversion system are being designed in different ways. We will talk about different designs or different classes of Wecs. And once the wind energy is converted, we need certain storage methods. Okay. Wind is not available always. Okay. It occurs seasonally or in a particular period of time. Then we have to produce the energy, that will be stored in some way. Okay. Because the energy need and energy production may be at different time. So once energy is produced, that has been stored and it has been used or distributed at a later period of time. So how this wind energy can be stored? Such techniques or technology we will be dealing with in this section on wind energy collection. And what are the different applications of wind energy conversion system? Okay. We will talk briefly about the applications of wind energy conversion systems. Okay. So these are the main topics to be discussed in this unit. Okay. So let us begin with wind formation. How wind get formed. Okay. So basically, what is wind? It is simply a motion of air core. Okay. Air from one place is getting displaced or moved to another place. That is literally known as wind. Okay. What is the reason for the production of wind? It is produced by the uneven heating of Earth's atmosphere or Earth's surface by sun. This is the general basic reason for wind production. What is meant by uneven heating? Uneven means different type of heating. Say one place, the atmosphere is heated to or Earth is heated to say 50 degrees Celsius. Say at the other place it is heated to say 40 degrees Celsius. And another place it is heated to 30 degrees Celsius. So this is called uneven heating. Okay, different types of heating. So temperature will be different. As a result, air will move from one place to another place. If temperature is same everywhere, then air cannot move. Then there cannot be any wind. So wind is usually what happens or occurs whenever there is a different temperature level or uneven temperature in a region. Okay, and this is happening because of the different reason. One is the rotation of the Earth. Other is what is called land and sea heating. Land and sea may be heated differentially. Okay, that is another case. And you see here, the Earth's surface is made of various land and water formations. So it absorbs the sun's radiation unevenly. This is one of the reasons. During daytime, sunlight is there. Land mass may be heated in a different rate. Water, reservoir water may be lakes, ponds, reservoir, canals, oceans, rivers. They may be heated in a different way. So this is called differential heating. Differential heating means heating in a different way. So that may lead to uneven temperature. This leads to the formation of heat. Okay. So what causes the wind to flow? As the sun warms the Earth's surface, atmosphere also gets warm. Okay, that is clear. And some part of the Earth will receive direct rays from the sun all over the Earth, and they are always warm. And whereas other places receive indirect rays, so weather is cold. So we have warm region here and we have cold region here. So what happens in the warm region? Air weighs less because it is hot. As a result, hot air moves up, rises up. Whereas from the cold region, what happens? Cold region, the air moves from the cold region into the warm region. This movement of air is what is making the wind blow. Okay, from a cold region, air moves to the hot region. Why? Because from the hot region, air always moves up. As a result, a vacuum, a free space is created at the hot region. Whereas in the cold region, pressure is high. So what happens? The air from the high pressure region or cold region moves to the hot region. That movement is called, or that movement is collectively called wind. I hope this idea is clear. It is a simple way to state the reason for wind. And there are many reasons for wind production. One of them is rotation of the earth. Rotation of the earth. How rotation leads to wind production? Let us see. You can see in this video, earth is rotating and the sunlight is falling over it. Okay. So what happens? Normally, vertical rays are falling at the equator. Vertical rays are falling at the equator of the earth. So at the equator, it will be more hot. Whereas at the polar regions, polar means the regions which are closer to the pole. At the pole, what happens? The sunlight is falling at a slanted direction, inclined direction. So intensity will be low, so temperature will be comparatively low. So what happens from the equator? Since temperature is high, air rises up and it starts moving towards the polar regions. Okay, this happens at the upper atmosphere. Whereas in the lower atmosphere, what happens? Very closer to the surface of the earth, cold air from the polar region comes towards the equator. So this cycle you can see. Hotter regions are shown with the red line, colder regions are shown with the blue lines. So a cycle is maintained throughout the earth. Okay, this is equally true for the southern hemisphere as well as the northern hemisphere. Understand? Even in the southern hemisphere, you can see hot air from the equator, the middle portion, moves towards the pole, and the cold air from the polar regions comes towards the equator. So this way there is a constant air current, constant airflow northward and southward. Okay, so that maintains a constant wind flow. So that is what is written here. Equator receives the sun's direct ray. Equator, as shown in the figure. Here the air is heated and rises up, leaving low pressure area behind. And this warm air moves towards 30° north and 30° south of the equator. 30° means around 30°. You know it. You have studied in the basic geography in schools. 30° north is somewhere here. All the hot air moves towards 30° north and it falls down. It comes closer to the earth's surface. This happens at both 30° north and 30° south. Okay, and between 30° north and 30° south, most of this cold air moves back to the equator. Okay, as they reach the equatorial region, what happens? Cools. So this cooled air moves back. This is the direction of equatorial, the bottom line. Okay. The rest of the air flows towards the pole. Okay, almost all air will be like this. Still, some portion will be moving towards the pole. Okay, this way a continuous cycle of wind is maintained throughout the year. This way, a continuous cycle. Okay. Throughout the globe, is a very gigantic picture actually. We have, for your brief understanding, we made it in a small picture. Okay, imagine the actual size of the earth and imagine the direction and the motion of this whole air. Okay, so it's something much what is called a miraculous event. Okay, so anyway, there is a constant inflow around happening throughout the year. Okay, and this is shown more clearly here. Okay, since India, for example, India is near the equator, so we are more towards the hotter region, whereas countries like Canada, Greenland, Siberia, in Norway, were year-round this cold. So this airflow can be maintained constantly throughout the year, no doubt, everywhere, irrespective of southern hemisphere or northern hemisphere, this will be there. Okay. That is the basic reason for the air current. You can say in general. So the second reason, as I told you, it is about the sea breeze and land breeze. Okay, one sea breeze and land breeze happen at day and night. One is happening at daytime and the other one is happening at night time. Sea breeze usually happens during daytime and land breeze happens at the night time. Let's see what is sea breeze. On a hot sunny day along the sea coast, differential heating of land and sea takes place. You know now the word differential. Differential means different levels. This leads to the development of local winds called sea breeze or land breeze. Okay, during daytime what happens? Land, shore will be readily heated. Its temperature will go up very fast compared to sea. So what happens? A low pressure is created in the lands and a high pressure in the sea. As a result, wind flow takes place from sea to the land. This is called actually what is called a sea breeze. Something which blows from sea to land is called sea breeze. Okay, sea breeze. So here it is written: when air above the land surface is heated by radiation of the sun, it expands and begins to rise. And why it is rising? Because it is lighter than normal air. So it rises up. To replace this rising air, because there is a vacuum, a cooler air from the sea is drawn from the surface of the sea. So this is known as sea breeze. So sea breeze is happening during daytime. During daytime, air near to the land is hot and rises up. A vacuum is created. As a result, comparatively cold air from the sea blows to earth. This is called sea breeze. Okay, sea breeze can offer a pleasant cooling effect on hot summer events. Okay, suppose you are standing near to the sea during daytime, you can get a cooler air flow. So this is due to sea breeze. Okay, and now let us see land breeze. Land breeze occurs during night time. Okay, then this is happening from blowing from land to sea. This occurs at night when the land cools faster than sea. Okay. At night, what happens? Land gets cooler faster than sea. So sea pressure is low. As a result, air above the sea rises up. Air above the sea rises up. Into that place, wind blows from land. At night, air above the warmer surface of the sea water is heated and rises up, thereby pulling in air from the cooler land surface. So this leads to land breeze. Okay, air blows from land to sea at night. This is called land breeze. Okay, so this idea is clear. And what is the prospect or the possibility or scope of wind energy conversion? The first reason is a renewable source of energy, because throughout the year it is there. Okay, it is never ceasing to produce. It's always there, wind is always there. It can never stop. And the global wind power potential is around 11,000 gigawatt. You know what is giga? Giga means you have to put around 12 zeros after 1. Only then you make giga. So that much. You have to multiply the given figure with 12 zeros again. So this is a tremendously high amount of energy. So that much potential the earth has, and it is around 5 times the current globally installed power capacity. Okay, so it shows that we have not yet tapped the complete potential of wind power. Okay, still there is a lot of wind energy which is yet to be tapped, which can meet our power needs. Okay, power needs. And interestingly, you see, this excludes offshore wind power potential. Okay, this value does not include our offshore wind power potential. In offshore means in sea, we can install wind energy mills. Many countries have already started. Still, there are so many places where we can install wind power mills in sea, in ocean. So that part is not here. So if you put that part also, the energy production is awesome. You cannot imagine its value. About 25 gigawatt is the current global installed wind power. Okay, so far we have installed only this much of power tapping technology, and it is around 1% only, 1% of the globally estimated wind power potential. So we can see the potential, the scope of this energy method. Okay, you can imagine. So a lot of technology required, manpower required, investment required. Okay, that's the very scope and importance of significance of wind energy conversion system. And you see, even in India, we have so many potential areas, okay, which are yet to be tapped. We cannot claim that the entire potential we have already tapped. No, we have tapped only few locations. Still, you can see many parts of the Western Ghats, including which are coming under the Western Ghats of Kerala and Tamil Nadu, and many places in Andhra Pradesh, Karnataka, Maharashtra, Gujarat. There are so many places, even including Rajasthan, where already one plant is there. Okay, so many places are there within our country where we can install wind power mills and tap the wind potential. Okay. And what is a wind energy conversion system, or Wecs? You can define it. It's a machine that converts kinetic energy of the wind into other useful form of energy. Okay, it can be any other useful form of energy. So it's a system which converts. So formally we can define a wind energy conversion system like this. Okay, and wind machines are typically used for mechanical applications like water pumping, grinding, wood cutting, or for AC or DC power generation. So many applications we can meet with the windmills or wind machines. So these are typical sites you can see in many European countries. Okay, many centuries ago they have installed such windmills in many places in most of the European countries and in America. You can see such mills. Okay, so they use the energy extracted out of such mills for various day-to-day applications. Okay, these are common sites in many Hindi Hollywood movies. You must have seen these visuals. Okay, so let us have a glimpses of the history of wind energy conversion. So first, it goes to thousands and thousands of years back. Okay, concept of harnessing wind energy to generate mechanical energy goes back to thousands of years. In BC 5000, the Egyptians used wind energy to propel boats along the Nile River. Okay, one of the oldest. Many artifacts of history shows that they used wind power to run their boats along the Nile River. And in AD 1200, Dutch people were pioneers in wind and mill construction. One of the previous slide shows such a figure. Okay, how they used windmills. Dutch means Denmark or Holland. Today's Holland is called Dutch or Denmark. In AD 1700, American colonists used windmills to grind food grain, pump water, and cut wood in sawmills. Used for various applications like this. And one of the remarkable events happened in 1926. Windmill was used for electricity generation. One of the French engineer known as George Darius. Okay, we will again come across his name in other occasions. George Darius used wind energy, windmill to produce electricity. These are major historical events happened in the technology of wind energy conversion. Okay, it's just for an idea. Okay, and now let's see what are the major components, major parts of a wind energy conversion systems. The first one is tower. Okay, tall tower or pole on which the entire system is fixed. That is called tower. And second important part is rotor. Rotor means something which is rotating. So if you have seen, if you come across any windmill, you can say a rotating part. Something like a fan blade you must have seen. That is actually called a rotor. And blades are in fact they are the long leaves which are fitted over the rotor. They are the blades. Okay. High speed, low speed shafts are the fourth part. Okay. Shafts are required. They are used to convert or transfer the rotation to the blades. Okay. They are called high speed and low speed shafts. You can use any shafts according to the requirement. Okay. You can use a low speed shaft or a high speed shaft. Accordingly, the velocity of the speed of rotation will vary. And it's now is a gearbox. Gearbox is used to convert the rotation. Okay, a small rotation you can convert a fast rotation. or a fast rotation can be converted into a slow rotation. You must have heard about gearbox in vehicles, cars, buses and all. Gearbox is used. We will come. You will see in detail about gearbox, how it is working. Phenomena we will show you some animations. Then you will understand the detailed working principle of the gearbox. And generator is required to convert the mechanical energy into electrical energy. And sensors and air drive are the another important part, which is used to rotate. Okay, sensor and air drive is used to rotate the fan according to the direction of wind. You know, wind is always not blowing in the same direction. Wind may blow from different direction. Accordingly, we have to shift. We have to set the fan blades. Okay, rotor and blades. A device is used to set the fan blade towards the wind direction. That device is called yaw drive. Okay, and finally you have the power regulation control drive, which is required to control the power generated by the windmill. Okay, so that's basically electronic device which is set to provide or supply constant power from the device. Okay, these are the major part of a base wind energy conversion system or Wecs system. So we will discuss one by one in the later modules. And first, let us start with the rotor. What is a rotor? Rotor receives the kinetic energy from the wind stream and transforms it into mechanical power. So this is actually a rotor. You can see the rotor. Rotor is comprised of blades and a hub. This part is called the hub. Okay, you can see hub here is the blade. So combinedly we call it a rotor. A blade and a hub together. This is a hub. On the hub, the blades are fitted. Okay. Components of a windmill rotor are blades, hub, and shaft. Shaft is there inside. You cannot see the shaft. This is kept inside. The shaft is connected to the generator. Okay. And in order to gain a smooth running, smooth rotation, usually bearings are used. Bearings are provided to rotate them frictionless. Frictionless rotation is provided by bearings. Okay, so these are the details of rotor. Rotor is something, rotating part is called rotor, and there are designs with a single, double and multi-blade system. Okay, here you can see a 3-blade system, but there you keep in mind that there are single blade system, double blade system, and even more than 3 blades are also used in different other cases. Okay, rotors with a single blade run faster, but they create undue vibration. That's the problem. And such rotors are not visually acceptable. Okay, another interesting thing is that they don't give any visual beauty. So people usually don't prefer a single blade rotor system. And 2-blade rotor systems suffer from balancing problem, and visually they are not acceptable. And so almost all commercial designs have 3-blade rotors. 3-blade rotors. Some of these small wind turbines used for battery charging have more number of blades, say 4, 5 or 6. Okay, so but they are very rare. 6-blade systems are very rare. Mostly what you will see 3-blade system. And the size of the rotor, you can have windmills with a different size and shape. Okay, gigantic Wecs you can see, small units you can see. All those depends on the requirements of the power. Okay, and blades are fabricated with a variety of materials. Modern windmills don't use wood or metal. They use certain alloys, okay, alloys or certain composites known as carbon composites. So their weight is comparatively small, and they are very strong, structurally very strong. They don't easily get broken. But for small units, you can use wood or metal. But for big units, they don't use such things. Instead, they use fiberglass blades. Okay. Modern commercial units make use of fiberglass blades. Okay, and research is going on in this area to find out new materials which can be efficiently used as blades. Okay, it's an evolving technology. It's evolving, Now let's see what is a gearbox. So it is a gearbox. Inside there will be some toothed wheels. You can see these are tooth. So let's kept fixed on a wheel. So we call it a toothed wheel. This is usually used to convert the rotation. Usually wind may be blowing weakly, so rotation may be very small. So that can be converted into a speedy rotation by using such a gearbox. Usually, in a vehicle, for example, a car, there is a gearbox, which is used to convert the small rotation, used to transfer the rotation of the engine rotation into wheel. Okay, this is usually done using a gearbox. Okay, in a car or a vehicle. So such a device is also fitted in a windmill, where gearbox is important. Its role is to convert the rotation speed of the rotor into the generator. Okay, we have generator there, we have rotor there. So the intermediate agents, the mediator between rotor and generator shaft is gearbox. Okay, speed of a typical wind turbine rotor may be 30 to 50 rotation per minute. Whereas the optimal speed of generator may be around 1000 to 1500 rotation per minute. Okay, you see, rotor is rotating at 30 to 50. The generator has to rotate at 1000 to 1500. So a mediator is required. That mediator is gearbox. Its duty is to increase the rotation speed from 30 to say 1000. Okay, gearbox do this function. Hence, gears are fitted in the transmission to regulate the speed according to the requirement of the generator. Okay, it is shown here. You can see the gearbox is fitted here. Automatically, the gearbox control the speed, increase the speed of or increase the rotation speed. Okay, so settings are given accordingly. An ideal gear system should be designed to work smoothly and quietly even under adverse climatic conditions throughout the lifespan of the turbine. Okay, so accordingly they are usually made with very strong alloys. They are properly lubricated. Reliability is good. They have long life, and quality of the gearbox is very important. Understand? These are all engineering details. You don't need it actually. And usually what is called planetary gear systems are used. These are called the planetary gear system. Okay, so rotation of the rotor is given here, and these rotors are connected to the generator, so they produce the requisite rotational speed. Okay, so the more clear diagram is animation is shown here. This will give you an idea about what is done in a gearbox, or what is happening inside a gearbox. So that's why this animation is shown here. Hope the idea is clear. Now let's go to the third part. This is called nacelle. Okay, nacelle is an important part of any windmill. What is nacelle? The outer covering, the outer what is called housing. That's what housing is called nacelle. This is used to protect the entire things from external factors. Okay, usually this is exposed to sunlight, wind, every climatic condition. So these parts has to be protected from such climatic conditions. So that cover is called nacelle. So nacelle is the outer cover housing all the generating components of a windmill, including generator, gearbox, control system, and brake assembly. Okay, these are all inside it. So the outer covering is, simply understand that the outer covering is called nacelle. So that is the engineering name, technical name, and it protects the device from adverse climatic conditions. So that is very clear. Nacelle is simply the outer covering. Okay, so the remaining parts we will explain in detail in the next module, and here we conclude this module with a structural explanation. And here is the question for the assignment. Explain the relevance of rotor, gearbox, and nacelle in the big energy conversion system. Okay, you briefly explain these words. Okay, no need of elaborate explanation. Very briefly explain each and every word. What is the role of this thing in a Wecs system? Here the second question. Distinguish between sea breeze and land breeze. we have explained at the beginning of this module what is a sea breeze and land breeze. We can explain it briefly in your own words. Okay. So with these comments, I hope we can conclude this module. You are reminded to watch this video at least twice before attempting to do the assignments. Okay. Have a nice day. Thank you all.